Hello everyone, this is Xiaoyuan Zhong, an undergraduate student at UW Madison. Today I'm going to talk about a project related to participation bias in UK Biobank. In the past decade, thousands of papers have already been published using the 500,000 research participants in the UK Biobank. However, UK Biobank actually suffers from participation bias. The participation rate is merely over 5%, and comparing to the freeing population, the participants tend to be older, wealthier, and have a greater proportion of female. Participation bias could act as a collider and contaminate the results of genetic studies. But how to account for participation bias in UK Biobank is not a well-understood topic. Here, we propose a framework to estimate the liability of participation for UK Biobank samples. Using the estimated liability, we can construct sampling weight and use selection model to adjust for participation bias. We use a linear equation to model the liability on the entire sampling frame, and we are interested in estimating gamma. By a series of relationships between the multiple and marginal model, we can infer the multiple linear regression estimator gamma hat from the marginal logistic regression estimator delta tilde, which we can directly calculate from the data. We can calculate the participation probability from the estimated liability, and we define the inverse of this probability as the sampling weight. To validate our liability estimate, we ran logistic regression of UKB optional components response status on our sampling weight. Those who responded to the optional modules should be more likely to join the UK Biobank than those who didn't. We observed significant effect size estimate, with direction as expected. Specifically, a larger sampling weight would imply a lower participation likelihood, which corresponds to the negative sign here. We also incorporated the Heckman selection model into our framework. Expanding the conditional expectation, we can derive that this bias term is a function of liability. To account for this bias, we simply add this term as a GWAS covariate. We tested the performance of this strategy on self-conducted GWAS of educational attainment. Comparing with the regular EA GWAS, the GWAS after applying Heckman correction shows a very minor decrease in heritability, and the genetic correlation between two GWAS is 0.997. One of our future directions is to apply Heckman correction on more traits and see if we can find some patterns. That's all for my presentation. Thank you very much.